In IBM SPSS Modeler, as I mentioned to you, is one of the easiest to use, highly intuitive. As you can see on the right-hand side, it actually follows very closely the CRISP DM methodology. It even provides this file structure where you can put documents, images, artifacts to kind of organize your project in a CRISP DM type of structure. In real world projects, if a lot of people are working on the same project, this kind of a repository becomes necessary, almost required, so that everybody would be on the same page using the same collection of documents to derive the process model on the data mining side and do the pre-processing modeling and evaluation in a right and cohesive way. So what I want to do is, and you don't have to, by the way, use this CRISP DM folders. As I said, it comes in handy and useful, becomes useful, quite useful, if you're working with other people on the same project, using same collection of resources, so they can share everything amongst yourselves, so that everybody would be on the same well-defined path. So on IBM SPSS Modeler, at the bottom, as you can see, there are a whole bunch of tabs. The first one is called the favorites. It will keep track of which nodes, and they call this graphical icons as nodes, which nodes that you're actually using more commonly, and it will give them to you on that particular tab, so you don't have to go in and hunt them in other tabs. But I would suggest you go through each of these tabs and look what's in there. So the first one, again, it goes from left to right. So data acquisition, the modeling, evaluation, and so forth. So it actually follows a logical path. The first one is the sources. Where does the data come from? So it can actually import data from a SQL database, writing a SQL query, hitting a relational database. The very next one, the third one, is the var file. It's variable data representation file. So all the CSVs and .txts can be consumed using this node. And then you have the fixed length textual data file, and quite a few, especially government provided ASCII type text data files comes in that format. It's very hard to parse in many of the tools, but this particular tool provides this fixed length variable parsing module that will make it easier if you happen to have that kind of data set. And then it has the statistics file. IBM Cognos files can be consumed in it. All the IBM, of course, file formats are supported because now it's an IBM tool. Notice that it actually consumes SAS file. So what that means is that the file that you create in JMP and save it in the SAS format can be consumed and imported into IBM SPSS Modeler without doing any additional pre-processing and data conversion. Okay. The very next one is the Excel. It can pull in both older Excel files, XLS, as well as the newer XLSS files is the input data. Okay? Let me go ahead and delete that. When you click on it, it grabs it, and when you click on the workspace, it drops it there. The very next one is the record operations, meaning records are the rows, and then you can manipulate rows by sampling or conveniently selecting a subset of it. So it looks at the original data and grabs a subset of the rows based on what it is that you want to do with them. In your own project, I would like you to do all of these selection pre-processing steps outside IBM SPSS Modeler, because every one of these nodes has quite a few options in their dialog boxes that you have to set properly, which requires, investment of times. Whichever the tool is easier for you to get the data in the proper shape should be the tool that you should use before you actually come to IBM SPSS Modeler. Now, if you do it in IBM SPSS Modeler, I'm perfectly okay with that. I'm just giving you an advice, if you will, that will make it less troublesome on your part. If you want to do all of those here in IBM SPSS Modeler, the learning curve is going to be a little steep to learn all of these nodes and what they do, how they do it, and properly be able to do it. The field operation is similar to the record operation, but as opposed to rows, it manipulates the columns, the variables. So selection of the variables, assigning different types to variables. Which variables are input variables? Which variable is the output variable? Variable types, filtering out certain variables, they all can be done using some of these nodes in the field ops, field operations tab. The very next one is graphical illustration of the data. It's called the graphs. And it has a pretty neat stuff here. Again, there is a little bit of learning curve to be able to properly use each and every one of this. But if you want to use any of those, feel free to do so. They don't add to the modeling part, but they give you insight, intuition as to how the data is distributed, how the data items related to one another. But if I were you, if you are merging data in JUMP, why not create some of those graphics, those descriptive understanding of the data in JUMP as opposed to here? So I think it's easier to do it in JUMP since you already know a certain level of JUMP and build some proficiency using those functionalities in JUMP. The next one is the most important one, of course. It's the modeling. Again, on this tab, on the left-hand side, notice that it has all of the modules, then the automated modules, the classification, association, and the very last one is the segmentation, also called the clustering. When you select all, it shows you all of those data mining modules integrated in IBM SPSS Modeler. Some are classification, some are association rule mining, and some are clustering. Vast majority of them are of classification type. Okay, so if you click on automated, you will see there are only a few items. Automated means it uses multiple modeling types to take the data from the source and create predictive models, and then even compare them to one another. And we'll do a small exercise for that. I use these modules, the automated ones, as a screening, just to see which model types, neural networks, support vector machines, decision trees, tend to perform better than the others. Okay, and then once I identify the top 3, 4, then I go to the individual models and I do a more thorough modeling exercise, each and every one of them separately, to collect both the prediction accuracies on a holdout sample as well as the variable importance for that model type. Here we will use the auto classifier module in a few minutes using a relatively small data set. And then the output will give you, do you want to push the output into a table, into a matrix, into analysis? This analysis, the magnifying glass, is the one that we're going to use to create confusion matrices from the trained prediction models. As you'll see, it's quite straightforward. As is the case in any, almost every data mining tools nowadays, IBM SPSS Modeler has some mechanisms in place to consume and generate R code. So every analytics tool, because of the increasing popularity of the R statistical language, want to have the means to link into those class libraries, and IBM SPSS Modeler is another tool that actually does its own fair share on that particular space. The very first one is the exportation of the data at any step in the workflow, either into Excel or to a dashboard or more, preferably if you're using IBM, it seamlessly connects into, for instance, IBM Cognos dashboard infrastructure. It also pushes it into SAS format. And then there's IBM statistics modules. And then the very last one is the IBM SPSS text analytics. If you're going to do text mining, concept extraction, this is the tab that you're going to use. If you buy the tool from IBM, this particular tab will not come. You have to pay extra to get this text mining module integrated into IBM SPSS Modeler. Anyway, what I'm going to do is I'm going to start the short demo, quick and easy demo. What I want to do is I want to read a CSV file, because CSV, comma, separated values text file seem to be the common denominator of data format that any and every data mining tool out there, free or commercial, can easily consume and process. So I'm going to grab that, put it on the workspace. If you double click on it, it will open up its specification dialog box. The first thing that you do, it says file, you need to attach it to a CSV file. And I'm going to grab a data set called Churn. So idea here is to use several characteristics of customers to identify who amongst them are more likely to churn, drop out the service of your company. And it's, I think, specific to telecommunication company. I'm going to say open. And it pulls it in. You don't have to do anything in the first tab. As long as it's a CSV file, it knows exactly how to parse it. And notice that this checkbox, it says read field names from the file. When you click on it, it looks for the first row and it assigns the names of the rows using that names of the variables from that first row. It shows the data items, all of them, and the data format, estimated data format. No, so I'm going from left to right on each and every one of those tabs. And I'm not doing anything on the second and third. The first one, I select data. I didn't do anything else. I clicked on second and third just to see how it's mapping out. You can actually change the name it's given to each of the columns and how you want to use it in your own. But I keep everything the same. And then this is important, the types. This is where you can actually define all the specifications of the data, so you don't have to use any of the other, for instance, field operation nodes. Okay? So customer ID is an ID. So it's a unique value. And because of that, I don't want to use it either for input variable or output variable, and I want to assign it as the record identifier, okay? The very last. Notice the very last row is called the role that the variable is going to play in your predictive model. For this one, for this variable, it's the record ID, okay? And I want to use rest everything else because I pre-process the data outside IBM SPSS Modeler so that I can only include the variables that I want to use and nothing else. And I usually put the output variable at the end of the variable list. In this case, it's churn. Okay? And I would like that to be a target variable. And I want everything else to be the input variable. Okay, if you click here, read value, it will go into the data set, look at each and every variable, and it will bring out the data specifications. Okay? Notice that when it's yes, no, it automatically assigns a data type or flag to it. Since this is a CSV file, every data type that it assigns is based on what it sees in that column. There is no specification transferred from another tool into the IBM SPSS Modeler. Okay, so it's all based on the observation that IBM SPSS model makes on the data. Now, you can change this if you choose to do so. Okay, but I would not recommend changing a numerical variable to, for instance, a nominal variable. That would create large number of pseudo or dummy variables in the execution phase that will lead to a very large consumption of time to generate any kind of result. So whatever it detects, as long as it's not way off what it's supposed to be, I would suggest leaving it at that. And these are the types, these are the values, value ranges. So the first is the minimum, the second value is the maximum, right? All for the numerical. For nominal, shows you what the value set is. And this is also nominal, but because it only has two value, in IBM SPSS model, it's called a flag value. Yes or no, black and white, pass and fail, so to speak, right? Two value dichotomous representation of a single value. So I'm going to say, okay, it looks like we defined everything we want to define. Look how easy it is going to be to build a model. So I'm going to go to modeling. I'm going to go to automated. I'm going to grab this auto classifier, drop it here, click on the source, right mouse click, and say connect. And then go to target and click on it. Okay. Now it's pushing the data from the first node into the second node. Then double click here just to see what's inside. As you can see, there's quite a few options. It says rank the models, compare the models based on what? Lift versus profit versus. What I would like is the area under the curve, because it is based on true prediction on all of the class labels, not just one. Because if there is only a small percentage of one class versus the rest of the classes, the accuracy would be misleading. But if you use area under the curve, it takes that into account because it's looking at the total coverage as far as variability of data is concerned with a specific prediction model. And the Verilex one, it says number of models to use. So I think it's a mislabel. What it says is that how many models do you want to retain? How many top models you would like to see once I'm done with modeling exercise. As opposed to 3, I want to increase it to, say, 6. Okay? Because it's going to go through each and every one of them anyway. I want to see how different model types actually fare. The very next one is called the expert. There is nothing expert about it, but it shows you that it already selected decision tree, C5, logistic regression, and there's another one called the decision list. Hardly ever generates really competitive prediction results. So I'm going to take that out because we haven't covered the internal structure of that anyway. And as I said, hardly ever you see it dominating any of the other more sophisticated machine learning techniques. Bayesian network is quite new, up and coming, highly popular, again, recently classification technique. I'm going to take the discriminant analysis. It's another statistical technique similar to, not similar to, but came pretty much the same time, the logistic regression in 1930s for classification type problems. I'm going to keep it in there. They hardly ever produce results that are competitive against the others, but what I want to include here is this K nearest neighbor algorithm. It's seemingly simple, but it does produce beautiful results. So idea here is to find the similar records while you're assigning a record to a class label. So it's like finding the neighborhood in a multidimensional space for the record that you're trying to predict, and then predict the outcome of that similar to what was around it, right? If the records in a multidimensional space are all leaning towards yes, he's going to churn, then this particular sample that you're trying to assign a class value is in between those, it will assign yes to it. If it's mix of yeses and nos in the neighborhood, then what's going to do is it's going to look to see which label is dominating the other. So if it's like 3 to 2, 3 yeses and 2 nos, it's going to assign yes to it. Okay, anyway, we'll keep that and a whole bunch of other decision tree algorithms, one card, quest, and neural networks in there too. So 2, 4, 5, 8 different model type will be executed using a holdout sample. Okay, so I'm going to say run, and it might take a minute or two because it will go through one by one each and every one of those 8 model types to build prediction models and to test them on the holdout sample, and then consolidate results to show us which one is better than the which others. So it's in rank order, and it will order it based on the true accuracy of the model prediction, which is this ROC curve. It's called the receiver operating characteristics curve, or area under the curve. As I said, it's an unbiased with respect to imbalanced data set accuracy measured in classification type prediction problems. So while it's working, any question, any comment, anything that I can help you with, answer for you? None. And as you can see, the model is completed. Now, this data set has hundreds, maybe a little more than 1,000 rows of data. And because of that, it did not take long. If you use your own data, and if you use relatively large data, maybe tens of thousands of rows, if not more, then it might take a few minutes longer. So you might want to run it and go get a cup of coffee. By the time that you fix your coffee and come back and look at it, it might be completed. But it will take a little bit of time. Now, this diamond shape is the built model. Actually, in this case, it's the collection of models that it built. If you double click on it, it will show you what it built and what results it obtained. And in this case, interestingly enough, C5. Actually, this is the advanced version of C5 that has a lot of heuristics. Took less than a minute to build out of all the data sets. It gives you the maximum profit, the left, but the one that we're looking at, this overall accuracy and area under the curve. And weirdly, again, enough that it shows 100% accuracy in this small, probably simulated, cooked up data set that is available, publicly available on data mining websites to illustrate churn. So it's 100% accurate. The very next one came out to be K-nearest neighbor algorithm with 86.2% accurate. Look at the area under the curve. One means it captured pretty much all the variable that can be captured. The baseline is 0.5, so there is no model that can achieve anything less than 0.5. Anything between 0.5 to 1 is the contribution or predictive power of that particular classification method. Okay, so it lists all of those. There may be a variable in there that is making the models perform better than they should. Now, I'm going to cancel out of this one. I'm going to go to my data set. I'm going to say edit. I'm going to go all the way down to see if there is anything fishy that, well, the way that we would do that is I'm going to delete those two. Now that you know how to do collective model building, right? I'm going to delete these and I'm going to go to an individual classification model. And because C5, the decision tree, built the best model, I'm going to grab that, drop it here, connect my source into my decision tree algorithm, open the edit dialog box, and say I would like to do cross-validation, and I want that cross-validation to be tenfold. So what it's going to do is it's going to take the source file, split into 10 disjoint subsections, and build 10 separate models, each time using 10th of the data as the test data, and kind of aggregating the test results at the end and presenting it as a confusion matrix. And use partition data. I want to make sure that I want to get the predicted importance, because this is critical. At the end, if you see one variable is significantly more important than rest everything else, you need to dig in and see if that variable is available before you actually make that particular prediction. Or are you kind of cheating that you present the model, the answer, while asking the same question, right? In a slightly different form. So I'm going to go ahead and say run. It did not take long, as you can see. I'm going to double click on it just to look at the tree. I'm going to expand all of them. Notice what kind of tree that it actually built. So there is some knowledge, in-depth knowledge, that it's actually capturing. And on the right-hand side, right, you get your predicted importance for the target variable, which is churn. And the one that actually is better than the others, actually significantly, it's twice as important as the next in line, more than twice, is the long 10. Probably it's the tenure. It's how long the customer was with the company. Longer it is, more likely it is that they're going to stay with the company. And shorter it is going to drive churn. Income, internet usage, longitudinal month. Anyway, what I'm going to do is I'm going to actually give you this data set as well. I'm going to put it on D12 so that if you want to repeat everything or anything that we're doing here before you get into your own big data, right, you can do so to build some hands-on skills. And then once you start playing with your data, at least you don't have to deal with the technicality related to the IBM SPSS Modeler. The very next one here on the tab on the upper left corner, that's the model. If you click on Viewer, it will take a little while, but it will show you the tree. Okay? Now let me increase it. Show you how it actually presents the tree. That's the first node. It shows the distribution of the two classes, number of no's and number of yeses. Okay, percentage of yeses and no's. As you can see, there is an imbalance issue here. But decision trees tend to be better than the other model types to take care of not very significant, but in this case, 4-to-1 ratio is what you're looking at. There are out of 4, there are 3 no's and 1 yeses in the whole data set as far as how many churn and how many didn't. As we talked about this, it usually is a good and great idea to produce a good result to kind of balance this out by boosting this yeses at the level of no's. So the way that you would do that here is that if you replicate the records that has yeses twice, right, you might end up having at or maybe a little more than the number of no's that you have in the data set before you start the training. And then it shows how it actually splits the data. And then what is the next one that it splits? What values it splits it? And what is the outcome of the data split from that point on, from branch to branch to branch. So this is the textual representation of it. and this is the graphical representation of it. And it also gives you the summary of what it did and how it did it, and what variables it used and what variables it actually ignored. They're all listed in this particular tab. Now, I want to close this. Even though I close it, I don't lose it because it goes right in here, the outputs, in the model section. Right? This is the C5 model I just created, and this is the churn model that we create and we deleted. But because we trained the trained model becomes an artifact, and IBM SPSS model stores it and keeps track of it. And you can actually store it or save it for further use down the road. For instance, if you have new records that does not have the labels, all you have to do is link your data item to the new data and then connect that to the trained model by drag and dropping, and then that will become your true prediction model to generate results. And you can connect that to a table so that all the results can be pushed into a table, including all the independent variables coming from the source and the dependent variable, the output variable that the model is generating for you. Now, as I said, to be able to see the confusion matrix clearly, you go to this Output tab, you grab the analysis, the magnifier, drop it on the workspace, connect the two together, okay? Connect, not edit, but connect. Before you run it, I suggest open and see what's in it and what options you have. Make sure that you click on the first one. That's where it actually creates the coincidence matrices or confusion matrices for you. Maybe the third one is also a good indication where it actually calculates the area under the curve and Gini index for binary classifiers. Another accuracy measure. You don't have to do anything here. It's automatically selected for you, and say run. Here is your confusion matrix, accurately predicting every single one of those records. Weirdly enough, as I said, because this is a makeup data, and I don't think it's actual, they put strong enough signals in there that leaves nothing out for predictability purposes. And C5 in this kind of data sets tend to be superior to any other model type because it gets into nitty-gritty details of the signal itself in the data set to build a prediction model that actually does an exceptionally good job. And in this case, it's a perfect job. When you see perfect job, you should be suspicious of it if it's real data. You can hardly get, and you shouldn't get, 100% accuracy in any data set if it's coming from a real world phenomena. Okay? Now what you can do here is that you can export it, or you can actually copy and paste it into your document so that you would have what C5 produced. Again, this is one aspect of it. The second aspect, and probably more important aspect, is the variable importance chart, right? That we looked at on the model side. This is very important because this is where it says, is this a collective contribution, or is that a variable that predicts everything without using any other variable in connection with it? So we're looking at the most important variable, and we see that that really is not a cheating. I mean, we will know how long each customer has been with us when we predict which customers are more likely to drop out. Okay? And it's not the only one, actually. As you can see, in a 0 to 1 scale, is 0.2 is the importance covered with that one variable. The very next one is 0.08, 0.07, and probably if you slide the slider down, you'll see that quite a few variables ever so slightly contributes to the perfect, in this case, prediction model that actually built. Any question? I would not suggest you to try to copy and paste this big graphical tree on anything, especially for a model like this, because it's huge. Let me zoom into it and show you how big it is, and there is no way that you can fit this in any paper. If it's a digital format, it's perfect. I mean, you can move around and show different subsections of the tree and talk about it, but to be able to show the whole big picture in a single paper or signal one screen is impossible. Okay, what I want to do is I want to show you how you switch from one model to the next. Now we like that, and what we're going to do is we're going to delete this model because we already have it here. If we want to, test it and look at results of it again, but I want to go to modeling. I want to go to classification, and I want to use, in this case, maybe logistic regression. Or right here, logistic regression. Or should we use, let's use logistic regression first. Connect the data, because we already specified the data. Okay. And the way that I'm connecting them is that if you push Control and Alt at the same time, click on the source, it will create this connection link, and go to destination and click in there. It will make the automatic connection, as opposed to going through the menu of connect and then go to destination and click on it. Both of which is equally easy, I think. On the churn, if you double click on it, there's hardly anything that you want to do here unless you know what you're doing. The method that you're going to be using, entering into the model. So it's taking all of the variables and measuring their significance, as opposed to stepwise, forward, backward. It's using the rudimentary, good old-fashioned, using all the variables and leaving out the ones that are having significantly low p-values as they relate to the output variable. So I'm going to go ahead and say run. It generates result. Right click, connect, destination, then right click, say run, generate the confusion matrix. It's not as good as the C5, is it? C5 had 100% accuracy. This particular one have about 81% accuracy, but it's kind of misleading. Look at here. Coincident matrix. Rows show the actual. So these are the actual yeses. Out of all the actual yeses, which are 258 of them, only 130 were classified accurately. So it's like a little better than 50%, right? 130 versus 128. Gini index, good but not great. So I'm gonna close this. Let's double click on this and see what model it actually generated. These are the equations for yeses and nos, and these are the model parameters. If you want to operationalize this in any other tool, all you have to do is operationalize this linear equation, and once you plug in the values of the variables for a new record, it will generate the result for you. Okay, I'm gonna cancel out of this, delete this too, and then use one more model. Okay, and in this case, I'm gonna use neural network. Where is my neural network code shade? Right here. Okay, and right click, say run. Well, before we said run, it's always a good idea to double click on it and see this is the target variable, these are the predictor variables. Build options, again, as I said, leave it at the default settings. But you can play around with it if you wanted to. You can change the neural network model from, for instance, multi-layer perceptron, which is 90+% of all predictive type neural network models are of this type, but you can use something like radial basis function. You can use one and then build another one with the other one and compare to see which neural network models actually predict better. But you don't have to do any of those. And all you have to say is, in this case, we actually already run the model. Double click on the model. And neural network output actually is a little more graphically appealing. It gives you the accuracy somewhere around 80%, so it's not 100%. Gives you the variable importance of the model parameters. And same thing actually applied to also logistic regression that we did not quite look at. Notice that here, long 10 became the second most, and tenure became the first. Little better than the second one, graphically speaking, because it rounds the numbers up. It looks like they're exact same, but if you look at the graphic, tenure is a little larger of a bar than long 10 is. Confusion matrix, and the pretty one is this neural network architecture that actually draws for you. That shows you this is the input layer, this is the output layer, and this is the middle layer. And those are the connections, weights. And the strength or the thickness of the weights shows you the importance of that variable connecting through the middle layer into the output layer. It's not visible per se in this particular case, but in some of the data sets, one or two of these lines from start to end tends to be thicker, significantly thicker than the rest, kind of showing the connection strength in between neurons, right? Analogy to brain structure, kind of leading to that variable, that input variable, being more important than the others in predicting the outcome. Okay. Let's see how good it was. So let's take this, connect it to analysis, right click, say run, and it's about 78.8% accurate. It's doing very poorly on classifying yeses correctly. It's less than 50% in this case. Out of 258, only 100 of them were accurately predicted as are more likely to churn. And even area under the curve is significantly less than even logistic regression in this particular case.